everyone. In previous lecture we have seen electric motor, the principle, construction and working of electric motor. The electric motor works on the principle of Fleming left hand rule, and the Fleming left hand rule also we have seen from the previous activity. So we have seen what is Fleming left hand rule and the electric motor. Now today we will start with a new topic, that is electromagnetic induction. According to the Xth state, we have studied that a current carrying conductor produces magnetic field, and that magnetic field is perpendicular to that current. That is from the right hand rule we have seen, and for that we have seen three different activity also. So according to the right hand thumb rule, so what is right hand thumb rule? That is, if we hold any straight current carrying conductor, so suppose this is a straight current carrying conductor, and if we hold the straight current carrying conductor in a right hand, then the thumb represents the direction of electric current and the wrapped fingers indicates the direction of the magnetic field. And how they are? Both are perpendicular to each other. That is, this is the direction of electric current, and this is the direction of magnetic field. So electric current and magnetic field both are perpendicular to each other. Means we have seen that any current carrying conductor produces magnetic field. We had also seen that whenever any current carrying conductor is placed in a magnetic field, and that magnetic field and electric current both are perpendicular to each other, then that magnetic field exert force on that current carrying conductor, and due to that force the current carrying conductor can move, and the best example of it is nothing but the electric motor. So that for that also we have seen an activity, that is when any electric straight current carrying conductor is placed in a magnetic field, and if that magnetic field and the current flowing through the conductor both are perpendicular to each other, then that magnetic field exert force on the current on the conductor, and that force is also perpendicular to the magnetic field and the current. Now here we have to see that can the magnet produce the electricity? That is, as all we have seen that the electric current produces magnetic field. Now we have to see, is the magnetic field produces electricity? Now the Michael Faraday, the English scientist, was the first person who proved that magnet can produce electricity. And how the magnet can produce electricity? For that he consider and he do an activity. And what is that activity? Take a coil, suppose this is a coil AB, take a coil AB of large number of turns, and the two end of that coil is connected to a galvanometer. Now what is galvanometer? Galvanometer is an instrument that is used to detect the presence of current. So it is the instrument which is different from the ammeter, because ammeter is the instrument that is used to measure the amount of electric current flowing through the circuit, and galvanometer is the instrument that is used to detect the presence of current. So this galvanometer is the instrument which is used, is the current is present or not, is the current flowing through the circuit or not. So that is detected by the galvanometer, and how much current flowing through the current is detected or is measured by the ammeter. So current measured by the ammeter, but current detected, is the current present or not, it was detected or it is detected by the instrument that is called galvanometer. So the two end of that coil is connected to a galvanometer. Now this galvanometer, and in galvanometer there is a needle which is deflected. So whenever the deflection in the galvanometer, so whenever the needle get deflect, it indicates that there is a presence of current, and the direction of deflection of needle shows the direction of current. So if the deflection in the needle is on right hand side, then it indicates the direction of the current, and if the needle deflect towards left hand side, it means that the direction of the current is reverse, or we can say the current move or current flow in an opposite direction. So whenever the needle deflect towards right, that is the direction of the current through that circuit, and whenever the needle deflects towards left, it indicates that current flow in an opposite direction. So that is the galvanometer. So in a galvanometer there is a needle which indicates the direction of the electric current. And which is the galvanometer instrument? That instrument which is used to detect the presence of electric current. So here we will take a coil AB having large number of turns, and the two ends of that coil is connected to a galvanometer, and then we take a bar magnet. Now initially in first diagram the bar magnet is stationary. It just placed near the coil, or it is stationary, it is not moving, just we place the magnet near the coil. So what is the deflection in the galvanometer? The deflection in the galvanometer shows 0. 0 means there is no presence of current. So whenever the galvanometer shows 0 deflection, it means that there is no presence of current, or current does not flowing through the coil. Now come to the second diagram. Now we move this bar magnet towards the coil. Now initially this is the bar, this is the magnet which is stationary. So initially the bar magnet is stationary, and therefore the galvanometer shows 0 deflection. Now the bar magnet move towards the coil. Now this bar magnet move towards the coil. Whenever the bar magnet move towards the coil, the galvanometer shows deflection. And which is that deflection? The galvanometer or the needle in the galvanometer deflects towards right. So the needle in the galvanometer deflects towards right. It indicates that current flowing through the coil, and the direction of the current flowing through the coil is given by the needle. So this is the direction of the current. Now in this case, or in diagram 2, we can say the bar magnet is moving. So whenever the bar magnet is moved towards, and how it moves? It moves towards the coil. Whenever it moves towards the coil, moving towards the coil. So whenever it moves towards the coil, the needle deflect towards right. Now in diagram 3, the bar magnet move away from the coil. Now in second diagram, the bar magnet move towards the coil. Now we move the bar magnet away from the coil. Move away from the coil. Now whenever the bar magnet move away from the coil, how the galvanometer shows deflection? The needle in the galvanometer deflects towards left. It indicates that in this case also the current flowing through the circuit, or current flowing through the coil, but in opposite direction. So whenever the galvanometer shows left deflection, or the needle deflects towards left, it indicates that the direction of the current get reverse. And whenever the needle deflect towards right, that is the direction of the current. So whenever the needle deflect towards right, that is the direction of the current, and whenever the needle deflect towards left, that is the current flows in an opposite direction, or the direction of the current get reverse. So what we can conclude from this activity? Whenever the bar magnet is stationary, then there is no current flowing through the coil, and therefore the galvanometer shows 0 deflection. Whenever the bar magnet move towards the coil, the galvanometer deflects, or the needle in the galvanometer deflects towards right. That indicates the presence of current. Or whenever the bar magnet move away from the coil, the needle in the galvanometer deflects left. That indicates current flowing in an opposite direction. So in both the cases the current will flow. It means that therefore we can say that, or the Faraday conclude that whenever there is an motion of an bar magnet, or there is a relative motion between the coil and the bar magnet, then and then the current will produce. And whenever the bar magnet is stationary, then current does not produce. So whenever the bar magnet is stationary, then current does not flowing through the coil. But whenever the bar magnet move towards the coil, it shows right deflection, and when it move away from the coil, it shows left deflection. It means that in both the cases the current will flow. So Faraday conclude that, or Faraday come to the conclusion that whenever there is an relative motion between bar magnet and the coil, or the large number of turns of a coil, then and then the current flowing through the circuit, and that current is called as induced current. Which current? It is called as induced current. So the current produced due to the relative motion between the coil and the magnet, that current is called as induced current. And whenever there is an induced current, then we can say that there is a presence of induced potential difference, because whenever we talk about the current, or whenever the current is flowing through an conductor, it means that there is always a presence of potential difference. So without potential difference, current does not flow from one place to another place. So whenever we say that there is a relative motion between bar magnet and the coil, so as long as the bar magnet is moving, then and then the current produces, and as the current produces through the coil, it means that there is a presence of potential difference, and that potential difference is called as induced potential difference, or it is also called as EMF, that is electromotive force. So induced potential difference, or it is also called as EMF. So whenever there is a relative motion between bar magnet and the coil, then and then the current is produced, and that current is called as induced current. And from this activity, Faraday proved that the magnet can produce electricity. But how the magnet can produce electricity? Whenever there is a relative motion between bar magnet and the coil. Whenever there is a relative motion between bar magnet and coil, then and then it produces current, and that is called as induced current. And in this way, from this activity, Faraday conclude that, or Faraday proved that the magnet can produce electricity. We'll see the conclusion of this activity. Now the first conclusion, that is deflection in galvanometer, indicates that current induced in the coil due to the relative motion between coil and the magnet. So whenever there is an relative motion between magnet and the coil, then and then the current will produce, and as the current is produced, it is shown by the deflection in the galvanometer. So whenever there is an deflection in the galvanometer, it indicates that the current is induced in the coil. And why the current is induced in the coil? Because the relative motion, because the current is induced only when there is whenever the magnet is moving into the coil. So whenever the magnet is moving into the coil or away from the coil, then and then the current will induce, and it is shown by the deflection in the galvanometer. And therefore deflection in galvanometer indicates that the current will produce, or current will induce in the coil. Now second, the direction of deflection in the galvanometer indicates the direction of the current flowing through the coil. So if the deflection in the galvanometer towards right, then it gives the flow of current through the coil. And whenever the deflection in the galvanometer move towards left, it indicates that the current flow in reverse direction, or current flow in an opposite direction. So the direction of the current is given by the deflection of the needle in the galvanometer. So direction of deflection in galvanometer indicates the direction of flow of electric current through the coil. Then next is rate of current is induced more for fast motion, and current is induced less for slow motion. So whenever there is a relative motion between magnet and the coil, so if the magnet moves slowly towards the coil, then the current will induce will be less, or we can say the rate of current produced, that will be less if the that magnet moves slowly towards the coil, and current is induced less for slow motion. So if if the magnet moves slowly, then the current will induce less, and if the magnet move fastly, or if the magnet move faster, then the current will produce more, or the current will induce more, and therefore the rate of current induced for fast motion, that is whenever the magnet move faster, as the magnet move faster, the rate of current induced will be more. As the magnet moves slowly, then the rate of current induced will be less. And the last is deflection in galvanometer changes with change in number of turns of the coil. More the number of turns in the coil, greater the deflection. Now the deflection in galvanometer, it also depends upon the number of turns of a coil, because whenever the magnet move into the coil, the number of the magnetic field lines also enter into the coil, and whenever the magnet move away from the coil, then magnetic field also move away from the coil, and therefore there is a change in magnetic field, and due to that change in magnetic field, the current will induce in the coil. So there you may have a question, how there is a deflection in the coil, or how the current is induced in the coil. So the magnet, if we consider, if we take any bar magnet, then the bar magnet has a magnetic field, and it is represented by the magnetic field line. So whenever any magnet move towards the coil and then move into the coil, then the magnetic field lines also enter into the coil, and when the magnet move away from the coil, then that number of magnetic field, so each turn of the coil get the magnetic field, and whenever each turn of the coil get the magnetic field, so each loop produces the electric current. So as the magnet move to and fro, that is, it move towards the coil and away from the coil, so number of magnetic field lines increases and decreases. So as there is a change in magnetic field, and due to that change in magnetic field, the current is induced in the coil. So if there are large number of turns, then the current induced will be more, and if there are less number of turns of the coil, then the less amount of current is induced, and therefore the deflection in the galvanometer. So deflection is also depend upon the current induced. If the current will be more, then deflection will be more, or vice versa. Deflection will be more, it indicates that the current will be more. So deflection in the galvanometer changes with the change in number of turns the coil. More the number of turns in the coil, greater the deflection. So as there are large number of turns, so if there are large number of turns, then the more current will induce, and if the more current will induce, it is indicated by more deflection. If there are less number of turns, then less current is induced, and it is indicated by less deflection in the galvanometer. So these are the conclusion from the activity. So hope you understand the activity very well. Now as we have seen the activity as well as the conclusion from it. So what is electromagnetic induction then? So in this activity we have seen the magnet can produce electricity, because whenever there is an relative motion between magnet and the coil, then it induces current. And why it induces current? Because at the same time there is an potential difference is also induced, that we called it as an induced potential difference. And why this potential difference are induces? Because of change in magnetic field. Because the bar magnet having the magnetic field in the form of magnetic field lines, and whenever the bar magnet go into the coil or away from the coil, then there is a change in magnetic field. So whenever the bar magnet move into the coil, the magnetic field lines get increased, or we can say the magnetic field get increased inside the coil, and whenever the bar magnet move away from the coil, then magnetic field decreases from the coil, and therefore there is a change in magnetic field, and due to that change in magnetic field, the potential difference is induced, that we call induced potential difference, and therefore the current is induced in the coil, that is we call induced current. So the process of the phenomena by which the EMF or current is induced in the coil due to the change in magnetic field is called as electromagnetic induction. So what do you mean by electromagnetic induction? Electromagnetic induction is the phenomena by which an EMF or current is induced in the coil. And why the EMF or current is induced in the coil? Because of change in magnetic field. And why there is a change in magnetic field? Due to the relative motion between bar magnet and the coil. As the bar magnet move towards or away from the coil, so due to this relative motion between bar magnet and the coil, there is change in magnetic field, and this change in magnetic field produces or induces current. So electromagnetic induction means the phenomena by which an EMF or current is induced in the coil due to change in magnetic field near the conductor is called as electromagnetic induction. So electromagnetic induction is nothing but the phenomena by which an EMF or current is induced. So in an electromagnetic induction, the current is induced or the current is produced is called as the induced current, and that current is induced in the coil because of change in magnetic field. So what is the reason of electromagnetic induction, or what is the reason the current induced in the coil? The change in magnetic field. And why there is a change in magnetic field? Because of relative motion between coil and the magnet. As there is relative motion between coil and the magnet, therefore there is a change in magnetic field, and as there is a change in magnetic field, then the current is induced in the coil, and that the phenomena or the process or the phenomena in which the current is induced in the coil, that process is called as electromagnetic induction. And its example is bicycle dynamo. In bicycle dynamo means you have also you have seen in an early age or in an early years, there is a dynamo, that is the light ahead on the cycle. So whenever there is an cycling, then it produces electricity, and due to that electricity the light can be glow. That is called bicycle dynamo. So it works on the principle of electromagnetic induction. So hope you understand the activity related with electromagnetic induction and the definition of electromagnetic induction. Thank you.